Everybody, Mr. Bowman here. This is another video for 2.12 probability methods. In particular, we're focusing on all the achieved questions from the 2023 exam. Just a reminder, all of these questions, they're from NZQA. They've been dumped on the Quick Maths website for your convenience. So maybe check the link out of the description for more questions. So let's get straight into question number 33. I won't read the context of this question just because it'll slow the video down a bit more. But basically, we've been given a partially completed probability tree. We've been asked, what is the probability that they drop the claw in the first game? And you can kind of see the first game happening here. And then wins in the second game. And you can see the second game happening here. So that kind of means this third and fourth game stuff, not relevant for this question. But it might have been relevant for the II, etc. parts of the question. So looking at the first game part, Alex, the person playing the game, they can or she can either win the toy, drop the toy, or lose the toy. We've been asked about the drop the toy group from the first one. And then in the second game, we can either win, draw, or lose. And we've been asked what's the probability of her winning the second game. So we're trying to find the probability that she drops the first game. So I'm going to write drop first, and then win in the second. So that's kind of what we're calculating. And the probability of that will be the two events times together. So it's going to be the probability of a drop in the first game, 0.15. We're going to go 0.15, and we're going to multiply that by the probability of a win in the second game, which is 1/9. So it's a bit of a fraction over there. Plugging that into our calculator, I always like to convert my answers to decimals for DP. So that, if I did that, would be 0.0167, and that there had a 4 DP rounding. So we are now on to question number 34, and this question carries on from Alex, who was playing that arcade game in the previous question. So when Alex goes to the arcade, 70% of the time she goes with her friends, which probably means the other 30% means she goes by herself, but we'll see. If she goes with her friends, she plays the claw game just once and wins 10% of these visits. If it's by herself, that kind of confirms the other 30% that we mentioned before. So let's kind of write that up there. So 30% would be by herself. She plays multiple games, and winning these is about 1 in 4 visits, or 1 in 4. So I guess what's happening is we're probably going to be drawing a probability tree, because the tree needs to be split off, or the outcomes need to be split off by whether or not she's going with her friends or whether or not she's going by herself. So I'm going to write F for the first split, so that's when she visits with her friends, and I'm going to write F dash, which means not visiting with her friends or by herself. After that, we're going to split off the friends one. When she's with her friends, she either wins or loses the claw game type machine, whatever it is she's playing. And we've been told she had a 10% chance of winning of the visits with her friends, and that's because she only played that claw game one time. So that means the probability of winning was 0.1, and the probability of losing was 0.9. I've actually just realized we haven't done the probabilities of our previous branches. As the question says, it's 70% winning with a friend, 30% going by herself. That means the friend one would be 0.7, and the by herself one, or not friend, would be 0.3. Okay, so we've done what we can so far. We're now going to split off. Well, if she goes by herself, she can still win or lose on this claw machine, but the chances have changed. So she's playing a few times by herself, and that means there's a bigger chance of 1 in 4 chance, or a 0.25 chance of actually winning on that. That means the other 0.75 must be down here as the probability of losing if she goes by herself. So we've done the tree. Let's actually look what the question's asking us. What is the probability that she wins the claw game on her visits to the arcade? So for each of the 4 outcomes, kind of in this area over here, we're going to give it a ticker across depending on whether or not that branch meets the criteria given to us by the question, which is winning the claw game. So first branch over here is a big tick because we can see the W here tells us she wins the claw game. The L over here means she loses it, so the question is not asking us to investigate that particular branch. We've got a tick over here because that is another win. And then finally, we've got a loss at the end, so we don't care about that particular branch. So what we need to do is we've got 2 branches which constitutes Alex winning the claw game. So we need to find the probability of each of those, and then we need to add them all together. So the probability of a win is going to be equal to the first branch, which is 0.7 times 0.1. So 0.7 times 0.1. And then we're going to have to add on the probability of the second one. So that's 0.3 times 0.25. 0.3 times 0.25. And plugging that straight into my calculator, I got a probability of 0.925. So roughly 30% of the time, Alex is going to come away from the claw game with a win. Okay, we are now on to question number 35. And we've got a survey of New Zealand media usages, and that was completed by New Zealand On Air. We've got the following results from a 2021 survey. There were 1,420 participants in total, and that kind of matches what we see on the table. We see that 1,420 total coming up a few times on my data. And they were asked if they watched each of the social media or each of the media types the day before. So by the media types, I'm assuming they're referring to if they watch online video, if they watch some kind of streaming service, or if they watch TV. The data was split between youth and New Zealanders 25 or older. So you can kind of see the youth data here and the 25 plus data here. And that was split off for the streaming services data, and then the same split for the TV data down the bottom there. So find the probability that a random survey participant is a New Zealand youth who watches streaming services the day before. So we're trying to find the probability that they are a youth and watched streaming services. I'll just write SS for streaming services. So this question is just a simple F over T type question. So the first thing we need to figure out, our denominator, is of the people part of the survey, who do we actually care about? So we've been asked about a random survey participant, and anyone in the survey will meet that criteria of being a random survey participant. So all 100 or 1,420 people is going to be my denominator, the total people part of the question. The F, or the numerator, that I need to put at the top, that relates to the people who are relevant to the question I've been asked. So we've been asked about youth and watched streaming services. So we need to look at our graph. So that's the streaming services section here. And we've got yes, and we've got the youth part here. So I think this 191, it relates to youth, and it relates to people who responded yes to watching streaming services. So that's going to be my numerator. So I'm interested in 191 of the New Zealand youth who watch streaming services out of the total 1,420 participants of the survey. Converting that to a decimal, and I'm getting 0.1345, and that they're at a 4DP rounding. Just a reminder, the way I convert that to a decimal is I literally just put this fraction, put it into my calculator as division, and that's going to spit out my answer, which I then round appropriately. We are now on to question number 35, and the question down here does carry on from the data we used in the previous table about the media types. So reading through the question, the report wants to include an infographic showing the daily reach of each of the various media. Find the overall percentages of New Zealanders watching each of the 3 media types, and I'm assuming what we're going to do is we're going to have to fill out the percentage of each people watching the media types down there. So let's start off with finding the probability. I'm going to write OV, probability of the online video ones. And we can see on our table the yes people up there, those 838, they're the ones who said yes to online videos. So the probability of watching an online video is going to be 838 out of the 1,420 people who did the survey. And converting that to a decimal, actually we're going to do it by a percentage, right? So I'm going to times them all by 100 to convert it into a percentage. And over here I got 59%, and that was rounded to the nearest whole number. So that was rounded to 0 decimal points. So putting that down the bottom there, I've now got 59% as part of my answer. So now doing the same for streaming services. So I'm going to do the probability of calculating, or probability of streaming services. So that was the 724 people. So it's going to be 724 out of the 100 or 1,420, times it by 100 to get to a percentage. And this time around, I got 51% for these people here. And again, that had the 0 DP rounding. So writing it down in my infographic down there, 51%. And then finally, the probability that someone's watching TV, same thing. That's these 795 people over here. So it's going to be 795 divided by the 1,420, timesing that by 100. And for this one here, I got 56%. So writing that in my infographic down there, 56%. So you did need all three of these correct to get the achieved mark for this particular question. So we are now on to question number 37. Just a reminder, all these questions are from the link in the description to this video. So if you wanted more practice questions, do have a look at that link. So similar kind of thing about media usages across different years. And we've got all the data. We'll look at that shortly. But how much higher is the percentage of New Zealand youth, so we're dealing with youth, who streamed services, so who use streaming services, and we're trying to compare the 2022 number and the 2016 number. Well, I guess let's start off with 2016. So we're trying to find the probability that they were youth and did the streaming. So I'm going to write S streaming. So that there is going to be, if you have a look here, so here's the 2016 data. And all of these people here are youth. So it's going to be 102 out of this 249. So that's going to be 102 out of 249, and converting that to a decimal number, I'm getting 0.4096. And just rereading the question then, it did specifically say percentage, but let's convert that to a percentage. Let's round that to 41%. So that there was rounded to 4 dp, and my percentage was rounded to the nearest whole number, 0 dp. So I've got that. Let's now find the 2022 number, because it's asked for the difference between these two. So let's get the 2022 number. So 2022, we've got 473 youth out of the 703 in total. So the probability of youth and streaming in 2022 was 473 times 700, over 706. Putting that into a decimal, I'm getting 0.6700. That was the 4 dp rounding. And timesing that by 100, 67%. And that was 0 dp rounding for that one there. So I've got my two numbers. So now I can just state my difference. So my difference here is going to be 67% minus the 41%. So that means it kind of increased by 26%. And just noting, putting the word increase in there, because it might have actually decreased, just kind of cementing my kind of mark for that question. Okay, we are now on to question number 38. So we've got a recent report of New Zealand youth spend an average of 113 minutes per day watching streaming services. We're going to assume the distribution follows a normal distribution, so that's nice. So it looks like we're using a normal distribution, and we've even been given the standard deviation. And then finally, we've been asked, find the probability that a randomly selected New Zealand youth spends under 92 minutes watching the streaming services. So as we always do for a normal distribution curve, let's sketch my diagram. So there's my diagram here. Down the middle is the mean, and in our case that was 113. The standard deviation, the question did tell us it was 35. If you're wondering where those numbers came from, we had 113 up here and 35 here. They were just given to us. And the question asked us for 92 minutes or less. So I'm going to draw in a line kind of randomly here, 92. And we're trying to find this shaded area underneath here. We're trying to find that probability. So on my graphics calculator, just a reminder, I'm going to be using my NCD mode. If you don't know how to use that, do let me know. I do have some resources I can help. The first thing you're asked to input is the lower, which is just going to be a negative big number with lots of nines. And then following that, we're then dealing with the upper, which in this case is 92. The calculator then wants you to put in the standard deviation, which is 35, and then finally it asks for a mean of 113. So plug that in. So the probability that X, or a youth spending less than 92 minutes on these streaming services, when I did that, I got 0.2743, and that had a 4 DP rounding. So let's get straight onto question number 39, which does carry on from question 38. So we're going to use the same information, but find the probability that a randomly selected New Zealand youth spends between 2 and 3 hours. So 2 hours would be 120 minutes, and 3 hours would be 180 minutes. So we're trying to find the probability somewhere in between that range there. So like we did previously, let's sketch my graph. We had 113 as the mean, the standard deviation was 35, and we were trying to find 120 to 180. So we're trying to find that shaded portion there. So same deal as before, we're still using NCD, so it is really important you know how to do that. Our lower, that's the lower limit of the shaded area. In this case, it's 120, because 120 is the lowest person we actually care about for the question. We're then looking at the upper, and the upper limit of my shaded area was at 180. It looks like a 181, but that is 180. And then we've got the calculator asks you for the standard deviation of 35, and then asks you for the mean of 113. So the probability that X is between 120 and 180, or between the 2 hours and the 3 hours that the question's asked us for, is equal to, and I'm getting 0.3929, and that there had a 4 DP rounding. So just a reminder, these basic finding the probability questions are really, really important. If you don't know how to do those, do reach out, ask for help, and I'm more than happy to reply with some resources to kind of make sure you're a pro at these questions. So that wraps up all the achieved questions for the 2023 video. A heap more achieved questions in this exam. I really hope you found this video useful. Now, good luck for your exam and keep practicing.